are seeing the eye of a hurricane photographed from a weather plane in the Caribbean. The eye of a storm is a relatively calm area in the center of a huge pinwheel, the largest and most destructive of storms in nature, the hurricane. In the right-hand corner is an electronic monitoring device. Man has no defense against the terrible forces of destruction unleashed by a hurricane. Or has he? The first halting, fumbling steps to control weather are already underway. Perhaps one day we shall be able to tame the wind. Man has changed the weather before now, without meaning to, sometimes without knowing he was doing it. Cities are warmer than the surrounding countryside, yet more rain, more thunderstorms, less sunshine. But man-made changes are not confined to cities, they are worldwide. Dr. Robert White of the United States Environmental Sciences and Services Administration.
There are things that have been taking place in the atmosphere that gives many scientists cause for very serious concern. For example, scientists are very concerned about what appears to be an increasing level of carbon dioxide in the atmosphere. Carbon dioxide arises in the atmosphere from burning of fuels, as in our automobiles or in our furnaces. And over the past several decades, measurements have been made at Mauna Loa Observatory in Hawaii, which indicate that the carbon dioxide content of the atmosphere has been increasing. Well, the consequences of a continuing increase in carbon dioxide would be that the Earth would warm up, because the Earth is very much like a greenhouse. The carbon dioxide acts very much as the glass in the greenhouse. And so we would have a tendency, if the carbon dioxide continued to rise, to warm up the atmosphere with all sorts of consequences. For example, were the atmosphere to warm sufficiently, you could have melting of ice caps or glaciers, with very serious consequences. However, nobody really knows at this time what the actual consequences would be. What we need to do is to establish monitoring stations around the world so we can be assured of what is happening to our carbon dioxide. We need to understand the atmosphere better. We need to be able to model it in a computer or in a laboratory so that we can simulate increases in carbon dioxide and determine what would happen to the atmosphere if such increases did come about. There are other effects that are taking place. For example, there's evidence that the dust content of the atmosphere has been increasing. This acts in the opposite way from carbon dioxide. It tends to cool the atmosphere. This cooling effect can also have serious consequences if we were to continue on certain aspects of the climate. Well, these are things that man must study. These are large-scale, global kinds of problems. They don't just impact one nation or one country. They impact all of us. And because they impact all of us, it's a problem of international concern, which must be addressed internationally.
To ventilate a city is just as important as to ventilate a house. Skopje in Yugoslavia lies at the narrowest point of a long valley, and pollution tended to accumulate and be held there. At 5:15 on the 26th of July, 1963, an earthquake destroyed much of the city. Damage to many buildings forced their demolition for safety. Skopje's replanners were given a unique opportunity to start with a clean slate. They could rebuild the city so as to give it the best possible microclimate. That is, the climate of a small area in which the weather is uniform. The problem in Skopje was the shape of the valley and the fact that the city center was at its narrowest point, an air trap that the prevailing winds could not ventilate.
Wait a moment.
Wait a moment. Here with this Orthodox church, this administrative building is now ready, and the church starts to become...
Adolf Chiborowski, a Polish architect, a rebuilder of war-devastated Warsaw, was sent by the United Nations to rebuild the earthquake-shattered city of Skopje. There he was confronted with an exciting, prize-winning plan for the new city center, submitted by the famous Japanese architect, Kenzo Tange.
Exciting from the point of view of architecture, of general concept, of functions. But when we started to examine this a bit closer, we started to wonder that probably it is unacceptable because of the local microclimatic conditions. The project presented by Kenzo Tange was suggesting to have a huge so-called city walls, a huge apartment buildings surrounding the city center, and this would be exactly a dam which would keep the smoke, the fog within the valley, which will close our windows. What was the main task, the main topic? To put the model of the city center into a tunnel, to create artificially winds, and to look which kind of wind and which kind of the construction of the buildings, long, short, tall, low, which interrelation between the buildings will help to have the highest flow of the air through the area of the city center. This was something quite new for all of us town planners. The aerodynamic tunnels were used until now to design the planes, sometimes to design the cars, never to design a city or an apartment building.
As a result of these tests, changes were made in the plan for the city center. Kenzo Tange's ideas were retained, but modified to meet the special microclimatic conditions of Skopje. Tange's shapes were reformed to encourage wind flow through the city. Low buildings combined with towers, working like a series of windows. They opened the city to the prevailing winds to carry away the pollution. Beside this medieval bridge, a new city rises from the destruction. A city planned by man to reverse his continuing destruction of his climate. What man does on the ground affects his climate as much as what he does in the atmosphere. This is the American Dust Bowl of the 1930s, a disaster made by people with just a little help from nature. It is just one of a series of man-made deserts. Our history has been a record of steady destruction of our climate, as we have gone about destroying the landscape. Israel in biblical days was a garden. Microclimate repair work is underway here on a national scale. Water is the main tool, and the Israelis claim rainfall increases of up to 15% from cloud seeding. Dr. Mordecai Gilead, head of the Israeli Meteorological Services.
Man has changed the microclimate, sometimes to the better and sometimes to the worse. And there are in this country certainly man-made deserts, through action or through inaction. Now, water resources on the one side, asking, for instance, whether fish ponds which we create in order to eat our gefilte fish, we need this. It's one of our mainstays, main dishes. It's the question whether we lose more money by spending for water than we get by getting fish here. It's a question of economy, not only of taste, but of economy, which we have gone into very thoroughly. You see all the forests being planted, and you see how delightful it is. People like to be in the shade, they have to be in the shade. People like trees and greenery, even if it needs more water than we could actually afford. And we are quite willing to pay this price for this creation of a microclimatic atmosphere. What we try today and we try already a number of years, is to improve the microclimate as the environment of men who lives in this country. We have made progress, perhaps even substantial progress, in doing this job of improving the microclimate. May serve as a kind of laboratory for all those vast areas in developing countries where we need the improvement of microclimate for the good of men.
Behind me, you see Lake Victoria, which is the source of the Nile, and it lies astride the equator, covering an area of about 60,000 square kilometers.
Jinja, on the shores of Lake Victoria, with its modern dam and hydroelectric station, is considered the geographic source of the Nile. In 1901, Winston Churchill said, "What fun it would be to make the River Nile start its 3,000-mile journey to the sea by jumping through a turbine." The water starts here and takes 3 months to complete its journey to the Mediterranean. It passes through some of the most desolate areas known to man, its people scratching out a bare existence.
They're coming now. They're coming in view. Good. They're coming. Now.
These men are at work in Uganda on the Upper Nile. They are charting the profile of the riverbed.
645
Their measurements will show the cross sections of the river, how wide it is, how deep it is.
89.7 degrees.
89.7 degrees. Good.
Down. Slowly. Down. No. Open side. Down. Down, down. Go down, go down.
At other locations, special instruments measure the flow of the river. This helps determine the total amount of water coming from the headwaters.
No, open it. Come on, open it. Keep it. Keep it.
All of this activity is part of a survey by the United Nations Development Program and the World Meteorological Organization. They are the first steps in a long-range plan that could affect the entire Nile Basin. Hundreds of people, widely scattered, performing seemingly unrelated tasks, are putting together a complete picture of the water resources of this vast area. In order to measure the level of the river, they have dug a shaft connecting to a tunnel, which leads to the center of the river. The water rises in the pipe to the same height as the surface of the river.
We adjust it to the required position and we put the
An automated recorder charts changes in the level of the water.
adjusted there.
Now we must try the chart first for 1 week run.
Oh yes, let's try it.
Because this is better for taking off the levels.
For taking all the levels
From
and,
the
and to
chart.
look how the watch is working.
Yes.
So when this level is up, it starts working. You can hear the clock? Can you hear the clock?
And
So now
the clock is working now.
the clock is working now. So
The purpose and objective of this entire hydrometeorological survey is to collect hydrological and meteorological data to study the water balance of the upper Nile. This in turn is expected to assist the participating governments in the formulation of schemes for the development of available water resources.
Lake Victoria, 60,000 square kilometers in area, gets great quantities of water in the form of rain and gives off great quantities by evaporation.
See the latitude setting and see that the correct card is put so that the center, the burn is at the center. Or parallel to or it should be parallel to this line. So that should be your aim. Now it is burning properly. Now the time is, you see, the standard time is about 3/4 of an hour behind.
Instruments measure the number of hours of sunlight every day. Count rainfall. And take all the other standard meteorological observations. All through the area, new stations were set up and existing stations upgraded.
Our dreams is that one day there will be a Nile Water Commission comprising from all these countries. And this Nile Water Commission will integrate developments of the Great Nile from Lake Victoria up to the Mediterranean by building dams, reservoirs, flood control, power generation and irrigation, which will change the life of our peoples. Our people are now living in dry areas. They do not find water for growing crops, nor even water for drinking. And we are very hopeful by this cooperation that the day will come when this integrated development of the Great Nile will change the life of the peoples and will change their microclimate completely.
Science and technology have advanced to the point where it is possible to dream realistically, to plan to change the microclimates along the Great River Basin. The history of man, and especially his efforts in the field of meteorology, has so far been directed towards learning to live with the weather as it exists. But now we're moving ahead a notch, not merely to live with it, but to turn the weather to our own ends.
Okay, Daypan 2-6.
The airline pilot and the traveler are even more dependent on the weather than most of us. The pulse of our civilization is the roar of the jet engine. However, in spite of all our electronic gear, an airport covered in fog represents a serious disruption. Here, too, the meteorologist is exploring techniques of doing battle with weather's individual phenomena. At Orly Airport in Paris, on an experimental runway, we are coping with this problem with some success. Jet engines capable of moving great volumes of heated air are buried beneath the runway. Their jet thrust is directed by special vanes into the fog-filled atmosphere. With the advent of a fog, the jet engines are turned on, they roar into life, and within minutes, the fog is dissipated. Rainmakers have always been with us. Through the ages, they have pounded drums, shaken rattles, and rolled through elaborate ceremonies. These present-day scientific rainmakers have considerably more knowledge and get considerably better results. They introduce tiny pellets of dry ice or silver iodide into carefully selected clouds. Not any cloud will do. When all the conditions are favorable, the moisture in the cloud is attracted to the new seeds. The droplets grow until they are too heavy for the cloud to support, and they fall as rain. Left to her own, Mother Nature supplies precipitation in a variety of forms, some less welcome than others. Hail does millions of dollars of crop damage every year, and Russian experimenters rose to the challenge. Around the valley in southern Russia, meteorologists have placed a network of observers to watch for approaching hailstorms. When the enemy is sighted, the warning is flashed, and the artillery unlimbered. The anti-aircraft rockets contain silver iodide instead of TNT, and the result of this seeding is that rain falls, not hail. The force of a hurricane is awesome. In 1969, Hurricane Camille caused vast devastation and loss of life, in spite of all warnings. After a 6-year wait for just the right storm, Hurricane Debbie came along in the 1969 hurricane season, and ESSA was able to perform an experimental seeding.
What we're engaged in now is really a basic research project which addresses a rather straightforward question with regard to the circulation of a hurricane. It asks the simple question: if you introduce silver iodide into supercool clouds near the eye of the hurricane and convert these water droplets into ice crystals, thereby releasing energy, would this have an effect on the circulation? We were able to calculate theoretically that if you can introduce energy into the central parts of a hurricane, you can reduce the wind speeds near the central parts of the hurricane. Our theory tells us these changes in wind speeds are not terribly different than some of those which would occur naturally. That's our problem: to find out whether, as a result of our seeding, we have really done something or whether it was just nature carrying out another unexplained variation. In our seeding of Debbie, what we've done is just this. We've introduced silver iodide crystals into supercool clouds around the eye wall, and we are now attempting to analyze to see whether the wind speeds have been reduced. This is the sole objective of the experiment. The most effect that we could hope to have on such a hurricane with this technique is very temporary. It does not appear from any of our theory or calculations that you could affect the direction of the storm or the speed of motion of the storm. You might be able to affect temporarily the speed of the winds circulating around the storm. This remains to be established, however. If one could do this, then it might be possible to consider ways and the logistics that might be required to maintain a continuously reduced wind field around a hurricane. You see, the hurricane problem is a complex one. Hurricanes are usually regarded, and of course they are, among the most destructive storms we have. They cause tremendous amounts of damage. This year, in Hurricane Camille, $500 million. But hurricanes are also beneficial. Along the east coast of the United States, about 30% of the rainfall that occurs during the fall months comes from storms that have a tropical origin, like hurricanes. That means that hurricanes also have a very beneficial effect. What one would like to do, of course, is to be able to modify such storms in such a way that you reduce their destructive effects without reducing their beneficial effects. This is a tall order. Nobody knows whether we can deliver. But I think everybody would agree that they're of sufficient importance, their destructiveness is sufficiently great, that we ought to understand these monsters better. We ought to ask the question, is it possible to modify them in some way? And someday, were we to gain an operational capability, we would have to deal with another class of problems entirely. Should we or should we not given such a capability, actually modify a hurricane? That's a question that remains for the future.
In weather as in life, one man's meat is another man's poison. What if this vineyard owner were to call on rainmakers to save his parched vines, causing it to rain, and at a nearby resort, ruining the business? What if these starving snowbound cattle were dying because the owner of some ski resort, perhaps in another country, had arranged for cloud seeding to make the skiing better? The problems are many. We must act on the basis of scientific information and international cooperation if we are fully to benefit from our ability to tame the wind.